this video will focus on linear regression. Linear regression finds the linear equation that best fits a data set. One common method is called the least squares regression line, or LSRL. This method looks at the sum of the squared distances between each data point and the line. In this graph, I have data points and a line, and notice all these dotted lines, those represent the distances between the points, between each point and the line. If I square each of those distances and add that all together, the least squares regression line is the line which makes this sum as small as possible. We will use technology to find the least squares regression line. So let's look at an example. The data we're going to look at is mass that's put on a spring and the length at which the spring becomes. Here's our data points. You might want to go ahead and try to work this with me. So go ahead and put your data into your calculator. So on the nspire from the home screen, to enter data, we want to choose the green tab here for stats and data. This screen will pop up. The first thing you always want to do is to label your variables. So up here, type in X or Y, or if you want to be specific about your data, you can go ahead and type in what the data actually is. Our X represented mass, and our Y represented the length of the spring. And you can see I've already put in the data in here, so why don't you do that with your nspire as well. Once you have everything in there, we can look at the data. To do that, go back to the home screen, and now to graph it, don't choose the graphing app right here, but instead choose the pink statistics tab right there. The data will always be all over the place. We need now to create or click our x-axis here and choose mass, and then also choose our y-axis right here, and that's going to be length. Now the data will line up with the appropriate axes labeled. You can see our data here. To create the regression equation, one way to do it now is to do it right from the screen, and that's to choose Menu, choose Analyze, and number 6 right here is regression, and there's all sorts of different types of regression. We're going to choose the first one, linear mx plus b. You can also choose the second one. Just remember that the a and the b represent different things here. But I'm going to choose the mx plus b, and voila, there's our equation right there. Y equals 0.04 x plus 18.1. And you can see how the line goes right through the data point. So it must have a pretty good correlation, but unfortunately this way doesn't give you the correlation. If you also want to find the correlation, another way to find regression is go back to home and come up with a blank screen. So that's choosing the calculator screen. When you're in here, choose Menu again. Now choose number 6, which is statistics. Right over to number 1, stat calculations, and to number 3, which is linear regression. Let me do that one more time, if I can, right? Let me come out of here. You're going to go to stats, go over to stat calculations, and then number 3 is linear regression. Now we have to put in some information. Our X list, right? We can either click in here, or arrow down, or I'm going to arrow over and choose mass for my X list. And that's probably a reason why you maybe don't want to label everything X's and Y's, because you're going to have different X's and Y's and you're not going to know which one is which. So I wrote mass down for my X, and then for our Y, right, again, click over or click down, choose length for our Y. Notice the third line says save regression equation. You don't have to do anything with that, but for right now, ours says F4. It may say different things depending on how many regressions you've done. Just keep that in mind that this one is F4. You could go ahead and type a word in there as well, but again, remember that that's F4. And now just go ahead and press OK. Right, and there is our information for the regression. Our m, which is our slope, is 0.04. Our b is 18.1, exactly the same as when we did it using the other method. But now we have r, our correlation of 0.99. And yes, it is a pretty high correlation. It also gives you something called r squared, or your coefficient of determination. And that's the percent of y values that can be predicted using this equation. So 98% of our length values can be predicted using this linear regression equation. Now, the one other thing I wanted to add, remember I told you to remember where we stored the regression equation? It was in F4. If we want to actually use our equation to make a prediction, you could write down y equals 0.04017x plus 18.1286 and then substitute in values for x to find different predictions, or it has that equation already for you at, in this case, F4, and if let's say I wanted to find a prediction at 10, I just need to now do parentheses 10 and press enter, and there's 18.5. Notice if I do F4 22, right, it will tell me if the mass is 22, how far the spring will stretch, and that's 19.01. So it's a great way to remember where your equation is if you either write it down or type in something else, but it's a great way to find predictions easily rather than having to do the calculations out themselves. So that's one way to do linear regression. Remember, the other one is straight from the graph. You can just do linear regression as well. So I can now go ahead and try the whisk.